trig, page 13, last page. Here's a triangle ABC. Write down the size of angle C. Find the area of the triangle ABC. Okay, so it's the same thing that we were talking about before. Except for this side, in this case, I only have one side, and then I have the angles. Okay, the only thing is here you're going to do a trick, which is if you have a triangle with two angles that are the same, you got to recognize that that's an isosceles triangle. If it's an isosceles triangle, that means it also has two sides the same, the opposite sides are the same. So that is actually 3. So we actually know two sides, and we also actually know the included angle because the included angle would be 180 degrees minus 50 minus 50. Okay? So the size of the angle C is 80 degrees. And the area of the triangle is going to be 1/2 AB sine C, right? So it's going to be 3 times 3 times the sine of C, which is the sine of 80. Okay, so it would be 9 divided by 2 times the sine of 80, which is 0.985. Okay, so that would be 0.985 times 9 divided by 2, 4.43. Okay, sounds about right. Moving on. Diagram shows a triangular field XYZ. Okay, so here's our drawing. YZ is 100 and XZ is 50, and we know one angle. Okay, now we're not ready to find the area of this because to find the area we would need to know an included angle, and we don't. So maybe we could use law of sines or law of cosines to find an included angle. Maybe we could find this using law of sines or law of cosines, and then we could finish it. So actually, like, look at this. We know this angle and we know this opposite side. So that means we could use law of sines for this triangle, right? So let's set that up. We're going to have sine of 100 over 100. That's one of the opposite side pairs. And then we'll use the fact that we know this side to figure out what the angle is for y. So we'll have sine y over 50. Okay, so let's see. What's sine of 100? That sounds familiar. I think we've done that already. 0.985. Yes, we have. Divided by 100, and then we'll multiply by 50, and then that'll give us the sine of y. So the sine of y is equal to 0.985 divided by 2, which is 0.492. So y is equal to the inverse sine of that. Inverse sine of that is 29.5 degrees. Okay, so now we know y. And if we know y, then now do we know it? No, now we still don't have it. We need to have two sides and an included angle. The sides we know are this one and this one. So the included angle that we need to know is angle z. But now that we know angle y and angle x, now we can figure out angle z. Because angle z is going to be 180 minus 100 minus 29.5. And that'll give us the answer. So 180 minus 100, so that would be 80. 80 minus 29.5, and the answer is 50.5. So z is 50.5 degrees. Oh, and that's what we wanted to know in the beginning, right? They're leading us through it. I'm making it harder for myself. They're telling me what to do. Okay, now the area. So the area is going to be equal to 1/2 times one side, 50, times one side, the 100, and then I multiply that times the sine of the included angle of sine of 50.5 degrees. So what is the sine of 50.5 degrees? It's 0.772. So I take 0.772 times 2,500, because 50 times 100 is 5,000, multiplied by 1,000 is 2,500, times 0.772. Okay, 2,500 times 0.772, 1930. So the area is 1930. That makes sense. The sides are about 100 long. Okay? Alright, last one of the chapter. There, you drew a picture for us. Find the length of DB. Let's see what we know first. We know this angle. We know this angle. We know this side. We know this side. We know this angle. Okay, and they want to know, first, find the length of DB. They want to know that. Oh, well, that looks easy, right? Because we we know two of the sides. We just need to do the third side. We have two options. One is we could use, tangent of theta, do opposite over adjacent, or we could just use good old Pythagorean Theorem, which is 6c squared equals a squared plus b squared. So the pink side, c squared, is equal to 25, 5 squared plus 6 squared, 36. 25 plus 36, 61. Take the square root, 7.81. So C is equal to 7.81, which is the answer to A. So it said what's the length of DB, right? So now we know the pink side too. Alright, now it says find the length of DC. Okay, DC is that one. Now we know two of the angles, and we know one of the sides, but we do not know, oh, good, look. So now we even know a pair. We know an opposite side and angle pair. So we're going to use, let's see, sine of 30 over dB. We're going to use law of sines. Sine of 70 okay, so we're going to find the length of DC. Yeah. Well, actually, it would be better, instead of using sine of 70, it would be nice if we knew this angle, because that would be an opposite side angle pair. Now, we can figure that out, right? Because we know that one of the angles is 70, one of the angles is 30. That would be 80 then. They have to add up to 180. So we'll do sine of 80, and then we'll put CD, DC. Okay. Sine of 30, I think it's 1/2. Yeah, it is. 0.5. Sine of 80, no idea. Something close to 1. 0.985. Okay. dB, we just figured it out. dB was 7.81. And then DC is what we want to know. So we'll cross multiply DC here. 7.81 times 0.985 here, divided by 0.5 here. Okay. 7.81 times 0.985 divided by 0.5. 15.4. So DC is 15.4. That looks about right. Okay, now C. Find the area of triangle BCD. BCD. Okay. Now, do we know enough to do that? Let's see. Now we know that side too. We know this angle too. So we do, because we know like two sides and include the angle. So the area would be 1/2 times the two sides we know, which is like BD I'm sorry, DB or BD, whatever. 7.81, right? That's 7.81. And then the new side that we figured out is 15.4. And then the included angle is 70, sine of 70. Okay, so we can do that. Sine of 70, 0.934, 940. And then we can multiply it times 0.5 times 7.81 times 15.4 equals, 15.4, 3310. Okay, that looks about right. It's like 15 long. Okay, that was C. Now D. It says find the area of the quadrilateral ABCD. Okay, so like the only thing we don't know is the right triangle. We never figured out the area for that, but that's easy. We just use 1/2 base times height for that. So it'd be 1/2 times 5 times 6. So it'd be 15. Okay, and then the longer triangle. Something's wrong. That's wrong, right? Oh, look what it did. So I want that times 0.5 times 7.81. Whoops. This is such a pain to type on this calculator with a mouse. 15.4. Okay, 56.5. Okay, that's better. Okay, so then for D, we're going to add up 15 and 56.5, and we're going to get, 71.5 or something. Okay, and that is the end of this unit.